So here we go. I thought I would share a few tips and tricks that I use in Fusion 360 when generating CAM for a part. So first off, what I want to show is when I'm working on a smaller part in a big model. For example, here is my modeled PrintNC for the most part, missing some of the upgrades I've done. But in this example, I want to generate the CAM just for this aluminum end cap part. So in order to do that, I want to pull out just this part of the model so I'm not worrying about having all of this added detail in the background, which generally slows down the processing of Fusion. I'm going to create a new product. And in there, I am going to derive a part from there. In order to do that, I have to have this targeted design saved. So I'm going to save and continue. And it's important to note that you need to save into the same directory as the part that you want to derive from. So my PrintNC model is in my as-built model folder. So I'm going to call it aluminum end plate. Keep it simple like that. So I'll save this part. Now it's going to pop up and ask me to select the source that I want to derive from. So in that, I'm going to dive into that same folder that I was at where my PrintNC model is. And for me, it is PrintNC. So I'm going to select that. So here we go. Now it's asking me to select the model object that I want to derive from. So two ways that you can do this. If you're just selecting a single body that you want to work with, you can select that body directly from the model, and it'll pop up here under bodies. So clear the selection. If you want to put in an entire assembly or you have a component that has multiple bodies in it, I highly recommend going into the product tree and finding the component that you want to select. So you can see here, it's got the component, it's got the bodies and the sketches. So if you have other features in there that you might want to incorporate, I'd suggest grabbing the whole component. And then, especially for setting up CAM, I like to place the objects, the origin, makes it easier to set up the CAM work coordinate system. So we'll press OK. Bring this model up into the screen. So I've got just that end cap that I want to work with. So now that it's in this separate design, I can pretty much manipulate it however I want, just like if it was a manufacturing model in the CAM. A couple notes about inserting drive. So if I modify the source of the drive in my main PrintNC file, it will prompt me with an out-of-date message in this local design, and it'll ask me to update. So if I change the source and then I come into this file and update, it'll make those same changes to this model here. If I make changes to this model, it will not propagate backwards to the source design. So any changes that I do in here are going to happen only in here. So again, this is very similar to making a manufacturing model in the CAM workspace without all the added resource requirements. So to show how some of that works, I'm going to create a mirror of this because I'm going to need two parts, one for each side of the cap. So I'm going to select this body, and I want to create a copy. And then I will drag it off and give roughly enough space for a 1/4 inch end mill to come between, and press OK. So now I've got this body, and it's created a new body. So what I can show you that I was talking to earlier, so the changes I make in this do not propagate back to the PrintNC file. So you can see in here, it's not spitting any errors on this. For example, if I was to modify a feature, so if I was going to pull this diameter of this circle smaller and press OK. Now when I go into my derived function, you can see that it's telling me it is out of date. So if I hit this button here, it will update and make this a smaller circle. So I'm not going to do that. I'll go back later and fix that, but just wanted to show that as an example. So now that I have the parts that I want to cut, I'm going to open up the manufacturer work environment to generate my CAM. So in here, I want to show you how I create a manufacturing model, as it's kind of nice to have a couple additional features in there. So under Setup dropdown, you're going to do Create Manufacturing Model. So you can see now under Models, there's a Manufacturing Model dropdown, and it's pulled in those two part bodies. So from that, I can right-click on the manufacturing model and do Edit Manufacturing Model. So now that I'm in here, it's a lot like the design workspace, pretty much identical features. And so I can make changes and edits in here without driving them back to my product design. And so these are changes that only exist in the CAM workspace. So for example, on this second end cap I have, I do not want this threaded hole here. So I'm going to delete that out. So now I've got my two end caps, one with the threaded hole and one without. And I will finish the editing of my manufacturing space. And to show that, so I can go back into design, and now my two end caps have the exact same features they originally did. But when I go back into my manufacturing workspace, so before I can start generating any toolpaths for my CAM, I need to get my setup created. So in there, again, in the setup dropdown, I'm going to do a new setup. All right, so now that I have my CAM setup created, I'm going to jump into a few of the features that I use pretty often. First off, the tool table. Um, I use my tool table a lot for two reasons. First, in Linux NC, I keep it updated to match my library in Fusion 360. Primary reason for doing this is my tool change setup on my router. When it calls out a tool change, it pops up a notification screen that alerts me of the tool number that it needs to change to, as well as the description of the tool. So by having that match my Fusion 360 library makes it easy which tool I'm swapping in without having a full-on setup sheet. Second thing I like about keeping my tool table up to date is setting cutting parameters for each tool that I use. So for each tool that you create in your tool table, you can update the cutting data and set preferred baseline settings for different types of cuts that you want to do. So to do that, select a tool you'd want to edit. Up here in the top, you can hit the Edit Tool button. And then in the second to last tab, Cutting Data, you can go in and set your spindle speed, your feed rates, both horizontal and vertical, and then any sort of step down and step over passes you commonly like to use. So you can go and add in additional presets, or you can edit existing presets. And so where this becomes helpful, if I want to, say, create a 2D contour, and I come and select my tool, so I can go into my library of tools, and for example, I want to use a 1/4 inch single flute end mill. Before selecting that, I can select the preset that I want to load that operation with. So example, I'm going to do some aluminum roughing, and I've got a higher chip load on that. And so I select that. And so now that I've loaded, it brings in that tool with all of those preset parameters. At the same time, in the tool tab, you can adjust to any preset that you already have loaded for that tool. So kind of a nice feature. I have these presets saved with parameters that I know work on my machine. So it makes it pretty quick to set up operation with that. Second thing I want to share are operation templates. So I think these are a huge time-saving feature. It allows you to basically generate an entire workflow very rapidly based on existing operations that you know work on your machine. So as I find a toolpath that works really well for me when I'm cutting a part, I will save them as an operation template. So it allows me to quickly load them for any future parts that I plan to cut that use a similar operation. So I'll show you how to create that operation template at the end. But let me show you a quick example of how I use these operation templates to really pull together a quick part. So in the setup, you can right click and there is a selection for create from template. So you can see here there's a list of my most recently used operation templates. At the same time, I can go into this select template and it opens up my template library. So for example, for this part, I want to do a spot drill of all my holes. And then I want to do a peck drill of my holes. I then want to do a large diameter bore of the remaining holes. And then I want to come in and finish up with a 3D adaptive clearing. So as you can see, I pretty much have a entire workflow for this part set up in a few seconds. The only thing I need to go in and do for each of these operations now is make sure that I have the appropriate geometry selected. But pretty much compile an entire program to create these two parts on my machine. So at this point forward, I would spend a little bit of time. So as you can see now, in just a few short minutes, I was dial in all the settings, make sure I have the right geometry selected, and dial down the surface finishes, probably add in a few finishing contour passes. But in general, it gets you to where you need to be in just a few short minutes. So one last thing I need to show you before getting out of this is how to create those operation templates. So say, for example, I want to adjust my boring operation to have a steeper ramp angle. So I'd go into my operation, edit it, in passes, and say I want to make this a 10-degree ramp. So now that I've created that operation with the new 10-degree ramp, I can right click on it and go store as template. And then I can come in here and rename it accordingly. So large bore op with steep. Now it is important in here to be pretty accurate with your naming and description, as when looking at your template operations, it won't give you the settings of the operation itself, so you need to be pretty accurate when you describe it to differentiate between the two. So I'll go ahead and save that. And now you can see if I need to create a new boring operation, I have a large bore op with steep ramp. Another way to see all the templates I have is to open up the template library. And here you can see a list of all the templates I have. This template library can also be opened up from the top ribbon, as seen up here. So another neat trick with the template library to speed things up even further. So I'm going to delete out all of these operations. And if I open up the template library again, I can select the sequence of operations that I want to run for my part. So I want to spot drill, and then I want to peck drill, then do a large diameter bore, and then do a 3D adaptive. Another feature I think is very handy in the manufacturing workspace of Fusion 360 is the compare and edit option. So this allows me to select multiple operations and see the settings for all of them side by side. Um, it allows me to filter for differences, make individual changes to operations, or make changes to all operations at once. So to do this, I select all the operations I am interested in looking at, and then I'll right click and select compare and edit. And it brings up this nice little chart, and it has all 4 of my operations across the top, as well as an edit all. Down here again, I can filter by which settings are different, which are non-default, which ones are editable, multi-edit, and which ones have been modified. So for example, I want to look at editable. So if I want to edit a single operation, so example, this drill here, I can select that box itself and identify the new parameter that I want. So if I want to change the plunge free rate to 12, I can change it and press enter, and you can see in blue that the value has changed. If I wanted to go through and change a variable for all 4 operations at the same time, say that I wanted to adjust my spindle speed for all of them, in this edit all box I can select it and say I want to make them all 12,000 RPM. So you can see now everything's been adjusted to 12,000 RPM, and it's in blue. So none of these changes will go into effect until I press OK. If I press cancel, it will cancel all changes and leave everything as is. If I press OK, it will identify that these operations have been modified, and it asks me if I want to update them, so I'll say yes. And then it goes through, and as long as you're not making any major changes that are going to affect the toolpath, if it's just RPM, for example, it adjusted my cut times, but not the actual path. So a very nice feature to make mass changes. For example, if you want to turn off coolant or change the type of coolant for all your operations, you can do it at once with that compare and edit. Okay, last thing I want to share that I find helpful are standard operation settings. So this allows you to save expressions or features in certain operation parameters so that the next time you load that operation, it will baseline to that parameter. So for example here, I'm going to look at the boring operation again, and I want to edit this operation. So let's say I want to change what my standard ramp angle is for a boring operation. So right now when I open this operation, it gives me 4 degrees. If I right click on that parameter, it gives me a couple options. One, I can save as the user default. I can reset to user default, or I can reset to the system default. So for example, the system default is 2 degrees. If I know that I want this to always ramp at, say, 8 degrees, I can set it to 8 degrees, right click, and save as user default. So now if I ever load this boring operation and it comes up and it's, say, 2 degrees, I can right click on that and go reset to my user default, and it brings it back up to 8 degrees. So a very nice feature to have. Another example of this working really well is for step overs. So a lot of times you want to set your standard step over to a percentage of your tool diameter. And where that's nice is that when you change your tool in the operation, it will automatically adjust. So what you can do is right click on that parameter again and edit the expression. And it brings up this expression editing window, so you can call it tool diameter. And then I can set it to, for example, I want it to be 20% of my tool diameter to be my step over. So I will press OK. And now it automatically accounts for being 20% of my tool diameter. Now, if I want that to be 20% of every tool diameter, anytime I load a boring operation, I can again right click on that and save as user default. So every time I load this boring operation now, it's going to go to 8-degree ramp angle and a 20% step over of that tool. And so for an example of that, you can see if I change my tool, so we can see if I change from my 1/4-inch single flute end mill to my 1/8-inch single flute, and say we're going to do aluminum roughing again. So if I go into my passes tab after loading that tool, I can see that my step over is not exactly 20%. So if I look at the expression, it is 50% of my tool diameter. So that is clearly the system default. So if I right click on that again and go reset to user default, it's now jumped down to 20%. And we can see that by going again to the expression and its tool diameter 20%. So just a nice feature to be able to set the baseline parameters for what you know works for your machine for future operation setups. So thanks for watching along. I hope you found some of that information helpful maybe and will help speed up some of your CAM generation for your projects in the future. Feel free to subscribe. I think over the next week or so, I was going to plan to put together a little tutorial on how to bring fixtures into your CAM setup. It's a pretty nice feature that Fusion 360 has where I can pull in a vise or a work holding fixture um, and the operations will actually recognize where that fixture is in the path and um, generate toolpaths that avoid the fixture as best as possible. And then you can carry on that fixture setup through the rest of your parts to make sure that it avoids that fixturing in the future. Um, so subscribe, stay tuned, and hopefully I'll have some more tips and tricks to share in the future. Thanks.